My dear friends, once again your Lalita ma'am is back to explain you about the concept of atomic structure. Most of the children are asking for the topics of EAMCET chemistry. So I started this concept of atomic structure. Okay, we will be dealing with certain concepts of atomic structure in this video, theoretical concepts, and then in the next coming video we will be learning about the remaining concepts of atomic structure. So in today's video we are going to learn only first part of the atomic structure. Okay, and in the second part we will be learning the remaining half of the lesson. So each lesson we will be dividing it into two videos so that we will be completing it as a crash course for upcoming students of intermediate, those who are attempting for JEE mains as well as for EAMCET. Okay, so kindly all of you please share the videos to the maximum extent and subscribe to my channel. Okay, please don't forget to subscribe to my channel. If you want more and more videos for the concepts of IIT and JEE as well as for EAMCET, you have to subscribe to my channel. Okay, this is your Lalita Peri ma'am, your chemistry teacher, and I am working for Peri's Study and Motivation channel. Okay, so let us start for the topic. Today we are going to learn about what? Structure of atom. This is the very important concept of chemistry, atomic structure. Okay, better I write a little bit down so that it will be visible to all of you. Right? Atomic structure. Okay, so in this video we are going to learn certain topics of structure of the atom. Okay, how atoms are being discovered. Okay, what is the main basis for the concept for the discovery of electrons. Okay, and what is the different atomic models that are being proposed by different scientists. Okay, different atomic models, and nature of the subatomic particles. Okay, nature of electron. Electron is possessing wave nature as well as particle nature. Okay, about all of that we are going to learn in this video. Okay, so first we are going to learn about electromagnetic radiations. Okay, what are electromagnetic radiations? Okay, so what are electromagnetic radiations? You all know that radiations are the process in which heat is getting transmitted from one place to another place without the requirement of any medium. Isn't it or not? Okay, heat transfer takes place in different ways. Okay, radiation is one of the methods in which heat is transmitted from one place to another place without the requirement of any medium. Sunlight is reaching to our earth, isn't it? Then it is passing through vacuum. You all know that, isn't it? So same like that, radiation is the process of heat transfer or the process of energy transfer from one place to another place without the requirement of any medium. You call it as radiation, isn't it? Now what are electromagnetic radiations? Electromagnetic radiations, in the name itself it is there. Okay, if two waves, one of electrical nature and another is of magnetic nature, you just consider one single wave like this and imagine that this wave is considered to be an electric wave. Let us represent it with E. And another wave of magnetic nature. Okay, if they superimpose with each other. Okay, if they superimpose with each other like this. Another wave of magnetic nature. One wave of electric nature and another wave of magnetic nature. If they superimpose with each other and travels perpendicular to the direction of propagation of wave. The particles of these waves travel perpendicular to the direction of propagation of the wave. Here is the direction of the wave. Okay, so these two waves, electrical wave as well as magnetical wave, are perpendicular to each other and the particles also travel perpendicular to the direction of propagation of wave. Such waves are called as what? Electromagnetic waves. And such waves you call them as electromagnetic radiations. Okay, using these electromagnetic radiations, okay, we can able to discover or we can able to detect the presence of certain small and very small subatomic particles which are present inside the atom also. Okay, now because of the presence of these waves only, we can able to see the very minute particles which are present inside the atom also. That's why first we have to study about these electromagnetic radiations, and then we have to go for the discovery of electron. Okay, here actually if we speak about the discovery of electron, you have to go with cathode rays, anode rays and all, okay, which you have already learnt in, from class 9 onwards you were learning about it. Okay, so regarding EAMCET, what are the concepts required? Regarding IPE, what are the concepts required? I am going through that topics only in this video. Okay, so what are the different electromagnetic radiations? What are the different types? Okay, now types of electromagnetic radiations, types of EM radiations. So what are the different types? Okay, you have lot many types of electromagnetic radiations. What are those? Cosmic rays, you know, cosmic rays. Second one are gamma rays. Okay, X-rays, you have heard about these X-rays. Okay, and then UV rays, infrared radiations, okay, IR radiations, and then electrical waves, radio waves, okay, radio waves, and then microwaves. Okay, like this you have lot many electromagnetic radiations. Okay, so based on the wavelength range that is being exhibited by them, okay, each one of these types of radiations have their own importance. Okay, in different science fields we are using the electromagnetic radiations. Okay, so cosmic rays, if you go for their sources and their wavelength range, sometimes they may ask this question. Okay, and you have to learn about certain wave parameters also, which we will be discussing shortly. Okay, right. So what are these cosmic rays and gamma rays and all? What are their wavelength ranges and what are their sources? Let us have a quick review of those rays. So suppose if you go for cosmic rays, okay, cosmic rays are having what? Just they are having very small wavelength of around 10 power minus 4 angstroms. Okay, and they are available from outer space. Okay, we don't have any special applications of these rays, of course. Okay, and if you go for the second one, gamma rays. Okay, now gamma rays are having a wavelength range of around 10 power minus 2 angstroms, a little bit bigger than cosmic rays. Okay, their source is what? Source is generally cathode rays. Okay, radioactive elements. From radioactive elements like uranium, thorium, okay, radioactive elements. All these gives you gamma rays, and their wavelength range is around 10 power minus 2 angstroms. And where do you use these gamma rays? Okay, they are useful for medicinal use. Okay, medicinal use. Okay, next we go for what? The third one are what? X-rays. X-rays are having wavelength of around 1 angstrom. Okay, now 1 angstrom, you all know angstroms are the units to measure what? Wavelength. Yes, 1 angstrom is equal to how much? 10 to the power of minus 10 meters or 10 to the power of minus 8 meters or 10 to the power of minus 10 centimeters. Okay, so gamma rays, after that what? X-rays. X-rays will have almost wavelength range of about 1 angstroms, and you all know these X-rays are used for what? Diagnostic purpose. Okay, now diagnostic purpose. Okay, to see any ailments or any fractures in bones or any accidents if they are going to occur. Okay, what is there inside, where actually the problem is lying inside our body, to check that we use X-rays. You all know about it. Okay, X-rays. And then what are the fourth type of X-rays? How they are produced? By the way, when cathode ray strikes the metal plate, okay, X-rays are produced. Roentgen experiment, once recall that. Okay, and next fourth type of radiations are what? UV rays, which have almost a wavelength range of 2000 angstroms. Okay, now 2000 angstroms wavelength is there. Source is sunlight. You all know that UV rays are produced from sunlight and even from arc lamps, klystron bulbs. Okay, source is that one. And where you are using these UV rays? Yes, UV rays are useful for structure determination. Okay, structure determination. To determine the structure of atom we are learning about. Okay, and at the same time structure of certain biological small minute particles like cells. Okay, we can use these UV rays. And even infrared radiations are also used for what? Structure determination. Okay, 2000 angstroms, just remember. And after UV rays, what we will come across? Visible region. Okay, now visible region. This is the very important thing. Visible region, very important, which can be visible to our naked eye. This is the only electromagnetic radiation region which will be visible to our eyes. Okay, so here what will be the wavelength range? 3800 angstroms to 7600 angstroms. Okay, you all know about VIBGYOR colors: violet, indigo, blue, green, yellow, orange, red. Okay, all those colors comes under visible region. VIBGYOR colors, rainbow colors. Okay, so visible region obtained by what? What is the source? Source of obtaining that visible region. You all know that it is sunlight. When particles of sunlight are made to pass through rainwater, each raindrop acts as a prism and accordingly dispersion takes place and accordingly you will observe the formation of rainbow. Isn't it? Right. So VIBGYOR colors. So visible region. And next, after visible region, what you will be coming across? Infrared radiations. Here infrared radiations will be again two types: near infrared and far infrared. I am going a little bit faster, okay, because we have to cover the whole chapter at a glance, right? Not even the whole chapter in this video, okay, at least half of the chapter we have to cover at a glance. That's why all going through a little bit faster. You have to cope up with my explanation. Okay, if you want, pause the video, just note down what all I am being writing on the board and please carry on with the concepts. Okay, your hard work, you have to do hard work a lot. Okay, because much time is not there and all the children have to be focused in this moment, isn't it? Okay, so we'll go for the next one. What is that? Infrared radiations, IR. In this you have two types: near infrared, near IR, and far IR. Okay, so you have wavelength range for infrared radiations is almost about 5 into 10 to the power of 6 angstroms. Okay, 5 for near infrared, 5 into 10 to the power of 6 angstroms. And here for far infrared it is almost equal to 10 power 8 angstroms. Okay, it is wavelength range only, it's not the exact value, please remember. Okay, next coming to after infrared we have microwaves. Okay, microwaves, you all know microwaves are used in ovens, microwaves. Okay, their wavelength range is almost around 10 to the power of 6 angstroms to 10 to the power of 8 angstroms. Okay, and used in what? Microwave ovens. You all know about that. And then we go for radio waves. Radio waves are the main waves which are used for radio broadcasting, radar applications. Okay, radio detection and ranging, radar applications, you all know. And even TV and radio broadcastings, how it is being possible. Okay, so that can be possible only with radio waves. Okay, they have wavelength range of almost about 5 into 10 to the power of 8 angstroms. Okay, radio waves. And then finally you have what? Electric waves. Okay, electric waves. So what are electric waves? They are wavelength and they are electromagnetic radiations of very high frequency, almost around 5 into 10 to the power of 12 angstroms. Okay, now 5 into 10 to the power of 12 angstroms. So like this you have different electromagnetic radiations. Right, children? Okay, you have to remember all these electromagnetic radiations which will be useful for you for getting objective questions from this topic. Okay, so be thorough with this. Right, now coming to the next thing, which we have to learn is about what? Wave parameters. What are wave parameters? Okay, if you have to learn about certain waves, you have to know about the characteristics that are being possessed by a wave. Okay, so you have to keep side heading wave parameters. So what are wave parameters? So you all know that. Okay, already if you want to have all these topics in detail, okay, you can watch my you can visit my channel Perry Study and Motivation. Okay, and you can watch the whole playlist which has been uploaded already long back. Okay, those who are very new to my channel, please go through all the topics which have been already uploaded, and please kindly subscribe to my channel. Okay, and share the videos as much as possible. Okay, right. So wave parameters. What are wave parameters? You all know that wave is a disturbance created in a medium. Okay, so you have certain wave parameters like the characteristics possessed by a wave. Like what? Wavelength. You all know it is wavelength denoted by the symbol lambda. Okay, the distance between two consecutive crests or the distance between two consecutive crests is called as wavelength denoted by lambda. You all know that. Okay, and then I'm not writing the definitions and all, as I already told you. If you want the topic in detail, you can visit my channel. You can go for the playlist over there. Okay, according to the topics, topic wise playlist has been uploaded already from long back. Okay, you can visit my channel and you can watch all the topics in detail. This is like a crash course. So what all the topics which are to be revised for EAMCET and other competitive exams, we are going with that, right? Wavelength denoted by the symbol lambda, the distance between two consecutive crests and the distance between two the two consecutive crests or troughs is called as wavelength, right? And then we have what we call frequency denoted by the symbol nu. Okay, the number of cycles made by a wave in 1 second, you call it as frequency. Here the units are what? Cycles per second or hertz. Okay, now cycles per second, or you can even take the units of frequency are what? Hertz. Here the units are what? Angstroms, picometers, nanometers, all those are the units for finding the wavelength of an object. Okay, wavelength of a wave, right? And the third parameter which you have after frequency is what? Frequency, after that you have wave number is there. Wave number, the reciprocal of wavelength is called wave number. Okay, now wave number denoted by the symbol nu bar. Okay, now wave number denoted by the symbol nu bar. The number of waves present per unit length, you call it as wave number, nu bar, and it is equal to what? The reciprocal of wavelength is called wave number. And then frequency, after that wave number, and then you have amplitude. Okay, now the next wave parameters are what? Amplitude. So the height of the crest or depth of the trough is called amplitude. Okay, now, so if a wave is like this, the maximum displacement point, you call it as its amplitude. This distance, you call it as amplitude. Okay, now, the height of the crest or the depth of the trough is called as what? Amplitude. Okay, this is also one of the important wave parameters. And it is also a distance, so it can be measured by units like centimeters, meters, angstroms, whatever it may be. Distance units you can apply even for amplitude also. Okay, the height of the crest or the depth of the trough is called as amplitude, right? And then we go for energy. Energy of a wave. What is energy? All electromagnetic radiations, okay, possesses energy E, which is directly proportional to frequency. This is according to Max Planck. Max Planck's theory also, I'll just will be learning about that shortly. Okay, so energy of electromagnetic radiations is directly proportional to frequency. E is directly proportional to nu, and E is equal to, proportionality symbol is replaced by equality symbol by keeping a constant h. Here h is called as what? Planck's constant. Okay, now Planck's constant, and you have the value for Planck's constant. Did you remember? How much is the value? 6.625 into 10 to the power of minus 27 erg second, or 6.625 into 10 to the power of minus 34 joule second. Okay, now, so this is the value for Planck's constant, and this equation you can even call it as Planck's equation. Okay, so this is energy, right? Energy. And wave parameters. In that wave parameters we also come across velocity. All electromagnetic radiations travels with velocity of light. You all know that. Okay, now velocity. Sixth one is what? Velocity. Okay, all electromagnetic radiations travels with velocity of light, and velocity is denoted by the symbol c, and c is equal to how much? Velocity of light, that is 3 into 10 to the power of 8 meters per second. Okay, now 3 into 10 to the power of 8 meters per second. All electromagnetic radiations travels with velocity of light only. Okay, so this is velocity. Okay, so these are all called as what? Wave parameters. Okay, so next we go for the next topic regarding in this atomic structure lesson. We go for another topic which is called as spectrum. Okay, do you hear about the word spectrum? Yes. Electromagnetic radiations altogether we call it as electromagnetic spectrum. Okay, spectrum is the arrangement of different electromagnetic radiations of different wavelengths or different frequencies. You call it as spectrum. Okay, the arrangement, spectrum is defined as what? Spectrum is defined as arrangement of EM radiations of different wavelengths arranged in an order. Okay, of different wavelengths arranged in an order. Different wavelengths, or you can even take them in terms of their frequencies as well. Wavelengths or frequencies, you call it as spectrum. Okay, so what is spectrum? Why we have to learn about spectrum? Okay, so electromagnetic radiations and electromagnetic spectrum. Okay, directly if you go for the concept, okay, you have two types of spectra are there. Okay, what are those? Absorption spectrum and emission spectrum. Okay, actually speaking, you have continuous and discontinuous, visible and invisible. You have lot many classifications are there in spectrum also. Okay, so that's why I am saying you please go through, visit my channel. Definitely you will be getting all these topics in detail. Okay, right. So absorption spectrum and emission spectrum. Okay, absorption spectrum. If light passing through, light coming from any source like electric bulb or tube light or anything, if it is made to pass through a prism and the transmitted light is analyzed through a spectrometer, then the spectrum which is so obtained, you call it as absorption spectrum. Whereas emission spectrum is obtained because of the excitation of electrons. Please understand the points carefully. Absorption spectrum, emission spectrum can be obtained from any source of light. Okay, if any source of light while it is emitting certain radiations because of excitation of electrons, you just remember like this. You have energy levels for orbits like this, energy levels. If electron jumps from any of the lower energy level to higher energy level, it will be unstable over there. So while when it is being unstable in that higher energy level, it tries to come back to its original state. While coming back, some of the energy is emitted in the form of radiation. That radiated light, if it is analyzed through spectrometer, okay, that radiated light, if it is analyzed through spectrometer, okay, you will be getting a type of spectrum. Okay, suppose if electron jumps from lower energy level to higher energy level, okay, then energy is absorbed. Suppose if it is coming back from higher energy level to lower energy level, then energy will be released. Okay, so when it is absorbed, when electron jumps from lower energy level to higher, okay, now lower energy level to higher energy level, some of the energy of the electron has been absorbed. Okay, it gets exhausted. So some of the wavelength of the light will be absorbed. Okay, and that wherever whichever wavelength of light is being absorbed over there you will find a dark patch on a bright background. Okay, so that you call it as absorption spectrum. Lower to higher energy is absorbed. Okay, then accordingly you will be getting what? Absorption spectrum. Okay, so emission spectrum means while energy is being emitted by the electron, when it is coming back to its original state, some of its energy will be given out in the form of radiation, and that radiated light gives you emission spectrum. Okay, so absorption spectrum is obtained whenever electron jumps from lower energy level to higher, and emission spectrum is obtained when electron jumps from higher energy orbit to lower energy orbit. Okay, so this is regarding absorption and emission spectrum. Okay, and emission spectrum always will be obtained what we call only by heated source of light. Remember, emission spectrum is always obtained by what? Heated source of light, like a candle or any incident radiations, like high intensity radiations, or if high amount of electricity is made to pass through gases under low pressure. Okay, high intensity electric field, if it is applied through gases gets ionized, then they give what? Emission spectrum. Some of the energy is being emitted in the form of radiations. Okay, that gives you emission spectrum, right? Absorption spectrum, if any wavelength of light is missing, okay, it will give you absorption spectrum. So absorption spectrum will have dark patches. Wherever light is being absorbed, you will find dark patches on bright background, whereas in case of emission spectrum you will find bright lines on dark background. So accordingly, absorption spectrum is always discontinuous. Remember, absorption spectrum is always discontinuous, whereas emission spectrum is always a continuous spectrum. Okay, and accordingly you have another classification is also there, line and band spectrum. Okay, now line spectrum is characteristic of atoms. That means, okay, if the heated source of light is in atomic state, then the spectrum which is so obtained, you call it as line spectrum. Okay, line spectrum is characteristic of what? Atoms. Line spectrum is characteristic of atoms, whereas band spectrum is characteristic of molecules. Line spectrum is characteristic of what? Atoms, whereas band spectrum is characteristic of molecules. Please remember. Okay, is characteristic of molecules. Means what? Here, if the heated source of light is in atomic state, you will be getting line spectrum. If the heated source of light is in molecular state or in the form of a compound, you will get band spectrum. Okay, characteristic of what? Molecules or compounds. Okay, so line spectrum examples you all know. Sodium vapor lamp, it's the best example, and most of the times it's being asked in the EAMCET also. Sodium vapor lamp. Okay, sodium vapor lamp. Sodium is in atomic state. Neon lamps. Okay, now wherever gas filled substances, lights will be there, disco lights and all, gas is being filled. If the gas is in atomic state, the spectrum which is so obtained, you call it as line spectrum. You will find in case of sodium vapor lines, you will find two bright lines in the yellow region. Okay, now two bright lines. Okay, in the wavelength range of 5890. Please remember, this is a very important point. Okay, two bright lines you will observe. In the yellow region of VIBGYOR, you will find what? Two bright lines. Okay, where you will find that two bright lines? Okay, just I'll write this side. Line spectrum, sodium vapor lamp, if you observe. The spectrum which is obtained by sodium vapor lamp. Okay, sodium is in atomic state, so it gives you line spectrum. Okay, now please remember, atomic state. Sodium is an atom, it's in atomic state. So atomic state, whatever the substance is taken in atomic state, it gives you line spectrum. Okay, so in case of sodium vapor lamp, most of the times this question is being repeated. Okay, two bright lines are observed in yellow region. Okay, now 2 bright lines. In which region? Yellow region. Please remember. 2 bright lines are observed in yellow region. Okay, one is at 5890 angstroms and another is at 5896 angstroms. Okay, in the yellow region you are finding 2 bright lines and that constitutes the line spectrum of sodium vapor lamp. Okay, if you are asked about band spectrum, it is characteristic of what? Molecules. Okay, so you can take potassium permanganate, KMnO4. This solution, if it is taken in a beaker and observed through a torchlight, okay, you will find 5 bands. 5 bands in green region of VIBGYOR. Okay, now 5 bands in green region of VIBGYOR, you will find 5 bands. Okay, now if you take KMnO4, potassium permanganate, either of these 2 examples may be focused. Okay, now for EAMCET orientation type questions, right, Chandran? Right, you can note down. Okay, so this is about line and band spectra. Okay, next we will go for what? Yes, please note down all the points. We will be going for Bohr's atomic model. Directly we will go for Bohr's atomic model. What are the different atoms made by? Okay, structure of atom means discovery of electrons, protons and neutrons. Based on that, you will not find much questions from EAMCET point of view. Theoretically, they will be very useful. For IP point of view, they will be very useful. But EAMCET point of view, if you go for, okay, you have certain important concepts which are to be dealt. Those concepts only we will be learning. Okay, so Bohr's atomic model. What is Bohr's atomic model? Directly I am going into the atomic models. Here Bohr's atomic model is based on Max Planck's quantum theory. Okay, now based on what? Based on Planck's quantum theory. So we have to learn what is this quantum theory first and then we have to go for the postulates of Bohr's atomic model. Planck's quantum theory. So Max Planck proposed, what he proposed? Energy of electromagnetic radiations is directly proportional to frequency. Okay, what he told actually about, okay, all electromagnetic radiations, okay, will have, as long as electron keeps revolving in the same orbit, its energy is fixed. So energy will be radiated in the form of small packets called quanta. That is what Max Planck told. Please understand the point carefully. Okay, theoretically what he said? Energy of EM radiations. Okay, now energy of electromagnetic radiations, EM radiations, energy of electromagnetic radiations will always be radiated in the form of small packets called quanta. Radiated in the form of small packets called quanta. This is what Max Planck told. Okay, means energy radiations. He was telling about what? Energy radiations. How energy is getting radiated. How energy is getting transmitted from one place to another place. He was telling that it will be transmitted in the form of small packets called what? Quanta. Called quanta. Quantum quanta. Okay. So this is theoretically what he said. Okay, mathematically how we are going to represent this Max Planck's equation? E is equal to h nu. Already I just told you before also. E is equal to h nu is Max Planck's quantum theory. Energy of electromagnetic radiations is proportional to, directly proportional to frequency. E is equal to h into nu, where h is called as what? Planck's constant. Okay, Planck's constant. Okay, and this nu can also be written as c by lambda. Okay, now h into c by lambda. So E is equal to what? h c by lambda. This is what you call it as Planck's equation, where c is what? Velocity of light and lambda is the wavelength of that respective electromagnetic radiation. Okay, so this is quantum theory. Now based on this quantum theory, Niels Bohr proposed his atomic model. So what are the postulates of Bohr's atomic model? Okay, you all are aware of this. Electrons revolve around the nucleus in a fixed paths called orbits or shells. As long as electrons revolve around the nucleus in a fixed orbit, its energy remains constant. Okay, only energy change will occur if it jumps from lower energy to higher or from higher to lower, isn't it? Energy change will occur. E2 minus E1 is equal to what? H nu. Okay, E2 minus E1 is equal to H nu, where E2 is the energy of the higher energy level and E1 is the energy of lower energy level. E2 minus E1 is always equal to H nu. This is one of the postulates of Bohr's atomic model. Directly I am not writing because already these topics have been uploaded very elaborately, okay, in the previous videos. Please check. Okay, Bohr's atomic model, Rutherford's atomic model, all those topics have been already uploaded. Okay, how to find the radius of the orbit, how to find the energy of the orbit, all those topics already explained. Once you go through the channel, visit the channel, and please don't forget to subscribe to my channel. For more better videos, I request all of you to please kindly subscribe to my channel. Okay, so E2 minus E1 is equal to H nu. E2 is the higher energy level, E1 is the lower energy level. Only if electron jumps from lower to higher or from higher to lower, there will be change in energy, and that change in energy is directly proportional to frequency, or proportionality symbol is replaced by the equality symbol by keeping a constant h, where h is called as what? Planck's constant. Nu is frequency. Okay, now h is Planck's constant and nu is frequency. Okay, so also he told that angular momentum mvr is equal to what? nh by 2 pi. Angular momentum, this is not new, mvr. Angular momentum mvr is equal to what? nh by 2 pi. Okay, this is called as what? Bohr's quantum condition. Based on this, you will be having certain numericals also. Here m stands for mass of the electron, v stands for velocity, r is for radius, h is for Planck's constant, and n is the orbit number. Okay, so angular momentum mvr is equal to what? nh by 2 pi. This is called as what? Bohr's quantum condition. Bohr's quantum condition. Okay, right. So this is these are the different postulates of Bohr's atomic model. Actually, Bohr's atomic model is very well explained for single electronic species. Mostly he explained for hydrogen atom. Okay, now, so if you go for hydrogen atom, okay, so hydrogen spectrum, he explained the concept of what? Hydrogen spectrum. Okay, so what is hydrogen spectrum? How we get different spectral lines in hydrogen spectrum? We are going to learn about that now. Okay, so in this EAMCET point of view, what are all the topics which are to be discussed? That only I am discussing here. Okay, so let us learn next about what? Hydrogen spectrum. So what is hydrogen spectrum? How you get hydrogen spectrum? Right? So hydrogen spectrum, how is it obtained? If you are giving 13.6 electron volts of energy is being provided for hydrogen atom. If you take a sample of a gas and 13.6 electron volts of energy is supplied, then what you will be getting? That electrons which are present in the hydrogen atom goes to the higher energy levels, as we already have discussed. Okay, electrons which are present in the sample of hydrogen gas which are being heated. Okay, if you take a sample of hydrogen gas and you are heating it, then by providing how much energy? 13.6 electron volts of energy. If it is supplied, okay, then you will be finding the excitation of electrons. Electrons are getting excited and they goes to the higher energy levels. This we have already discussed. So accordingly you will be getting what? line spectrum. Hydrogen is an atom. Hydrogen is in atomic state. So you'll be getting what? Line spectrum. So Niels Bohr have been discussed about this hydrogen spectrum in a very excellent manner. Okay, so what he told, okay, if you are providing 13.6 electron volts of energy is given to hydrogen atom or a sample of hydrogen gas, if it is taken and you are heating it by giving 13.6 electron volts of energy, then how electrons are getting excited, okay, and what type of spectral lines are formed. Okay, he explained very well about what? This line spectrum. Okay, so accordingly, atomic spectrum of hydrogen, if you go for, you'll be having a series of spectral lines. Atomic spectrum of what? Hydrogen. Series of spectral lines you will be finding. Okay, so what are the series of spectral lines which you will be finding when you are giving 13.6 electron volts of energy to hydrogen atom? Series of spectral lines are formed. So what are the different series of spectral lines? Okay, so you have 5 types of series are being discussed. Lyman, Balmer, Paschen, Brackett and Fund series. You all know. Paschen, Brackett, okay, and Fund series. Okay, so if you go for the series of these spectral lines, it will be very much useful to learn about hydrogen spectrum. Okay, so you all are aware of these spectral lines, right? Okay, if you go for Lyman series, just look at this small diagram which I am drawing here. So if electrons goes from any of the lower energy level to higher energy level, and if they return back to the ground state, 1, 2, 3, 4, 5, 6, 7. Okay, I have drawn energy levels 1, 2, 3, 4, 5, 6, 7. From any of the higher energy levels to ground state, if they come back, okay, now that means N1 is 1, N2 can be 2, 3, 4, 5, 6, 7. Then such kind of all spectral lines comes under the category of Lyman series. Okay, here Lyman series stands for what? If the series of spectral lines are formed by when electrons are returning back from any of the higher energy levels to ground state. Okay, ground state. Then series of spectral lines which are formed are called as Lyman series. Similarly, from any of the higher energy level to second orbit, if they return back from any of the higher energy level to second orbit, then they all comes under Balmer series. Okay, now Balmer series. This is Lyman series. N1 is 1, N2 can be 2, 3, 4, 5 and so on. Okay, Balmer series. N1 is 2, N2 can be 3, 4, 5, any of the higher energy level to second orbit if they come back. Then such series of spectral lines comes under Balmer series. Accordingly, you have, if they come to third orbit, you call them as Paschen series. Okay, now. Or if they come to fourth orbit, they are called as Brackett. If they come to fifth orbit only, they are called as Fund series. Okay, now. So accordingly, you will have certain types of spectral lines. Okay, Brackett, Fund, P Fund, right? So here N1 is 3, N2 can be 4, 5, 6 and so on. Here N1 is 4, N2 can be 5, 6 and so on. Any of the higher energy level to fourth orbit if they return back, you will find Brackett series. And here in case of Fund series, N1 is 5 and N2 can be 6, 7, 8 and so on. Okay, so accordingly you have series of spectral lines, and these are very well explained by Niels Bohr. Okay, and Lyman series falls under what? UV region, ultraviolet region. Okay, that means the wavelength range of the series of spectral lines which are under Lyman series, okay, are having electromagnetic radiations wavelength range of about UV rays wavelength. Lyman series spectral lines are having UV rays wavelength. Okay, And then Balmer series is visible region wavelength is there for Balmer series. Okay, Balmer series is the only series of spectral lines which can be visible to our eyes. Okay, now visible region. And this is Paschen series is for near infrared. Okay, and bracket is for infrared, near IR. This is IR. This is present in infrared region, and Fund series is present in far infrared region. Okay, so like this you have series of spectral lines, and these all constitute what? Hydrogen spectrum. Okay, so accordingly you have certain formulas are there to find the series of spectral lines. What is the best way to find out the number of spectral lines formed when electron jumps from any of the higher energy level to lower energy level? So the number of spectral lines, this is a very important formula. The number of spectral lines, the number of spectral lines that can be obtained is given by the formula what? N2 minus N1 into N2 minus N1 plus 1 whole divided by 2. Okay, now N2 minus N1 into N2 minus N1 plus 1 whole divided by 2. Here N2 is any of the higher energy level, N1 is any of the lower energy level. Okay, and if you apply this formula, how many spectral lines are formed when electron jumps from any of the given higher energy level to lower energy level? You will be getting the exact value. Suppose if you go for, if electron jumps from 5th orbit, if electron jumps from 5th orbit to 2nd orbit, okay, then what will, how many spectral lines are formed? Jumps from 5th to 2nd orbit. Then in place of N2 you will take 5, in place of N1 you will take 2, 5 minus 2 into 5 minus 2 plus 1 whole divided by 2. Okay, so 3, 5 minus 2 is 3 plus 1, here it is 4 by 2. So 12 by 2, which will give you 6 spectral lines. You will be getting how many spectral lines? 6 spectral lines. If electron jumps from 5th orbit to 2nd orbit, how many spectral lines you will be getting? Okay, that you can measure like this. Okay, and you have another important point which is called as limiting wavelength. What is limiting wavelength? That is very important point here. Based on this concept of limiting wavelength, you will be getting certain numericals. Okay, using Rydberg's equation. Okay, suppose what is limiting wavelength here? Limiting wavelength. In any of the higher energy levels, if the higher energy level is at infinity, if electron jumps to higher energy levels, that is infinity. Okay, which cannot be determined by us. That means what I mean to say is, if N2 is equal to infinity, then the wavelength of the spectral line which is so formed is called as limiting wavelength. Please understand the point. If N2 is infinity, I think you have to recall the Rydberg's equation for this. Did you remember what is Rydberg's equation? You can refer to my channel. Okay, what is Rydberg's equation? You have a special video on that, Rydberg's equation. Okay, please, playlist is already there. You can watch, and numericals based on Rydberg's equation, what type of numericals you will be getting, everything has been uploaded, okay, in the YouTube. So don't forget to visit my channel, okay, and especially don't forget to subscribe to my channel. Okay, please. Rydberg's equation. What is Rydberg's equation? Did you remember? Okay, so here nu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus n2 square. Okay, this equation you call it as Rydberg's equation, isn't it? Here n1 is the lower energy level and n2 is any of the higher energy level in which electron gets excited. Okay, r is Rydberg's constant, nu bar or reciprocal of wavelength. Okay, that value you are finding out. Okay, so in case of Lyman series, you know the n1 value, n2 value will be given accordingly. So accordingly, the wavelength of that spectral lines you can find with the help of what? Rydberg's equation. Okay, if in this equation, if you are going to keep n2 value to be infinity, okay, then the wavelength which is so obtained, you call it as what? Limiting wavelength. Okay, if n2 value is equal to infinity, you call it as what? Limiting wavelength. Okay, so remember that point also, very important. Okay, I expect all of you to please kindly write and practice. Pen and paper has to be there. Copy down what all your teachers are saying. Okay, keep your mind focused here in the concepts. Okay. So next we will be learning about different series of spectral lines. Already I told you. Suppose if you have n2 minus n1 difference, this n2 minus n1, if the value, if you are getting it as 1, okay, then you call it as that line is called as what? H alpha line. Okay, and if the difference of n2 minus n1 is equal to 2, you call it as H beta line. If the difference of n2 minus n1 is equal to 3, H gamma line. If the difference is equal to 4, then you call it as H delta line. Okay, so remember, these are the very important points which you have to remember. Okay, n2 minus n1, if the difference is equal to 1, H alpha, if it is 2, H beta, 3, H gamma, and 4, it is called as what? H delta line. Okay, please remember. Okay, and in this hydrogen spectrum, what I said, Balmer series is the only series which is visible to our eyes. Okay, visible spectrum is only Balmer series. Please remember that point. Okay, so you have accordingly certain wavelengths of like colored radiations are there. You have to remember that wavelengths also. Suppose if you are going for a red line with a wavelength of like if you are finding 4 prominent colored lines in Balmer region. Okay, now 4 prominent, this is very important point, 4 prominent colored lines you will find in Balmer series. Colored lines in Balmer series, because Balmer series is the only region which is visible to our eyes, which is there in the visible region of electromagnetic radiations, isn't it? So in Balmer series, 4 prominent colored lines you will find. What are those 4 prominent colored lines? So first one you will find a red line with a wavelength of 6562. With a wavelength of 6562. With a wavelength of 6562 angstroms, and you will be finding a bluish green light. Okay, now a line with a bluish green line with a wavelength of 4861. Bluish green line. This is also prominent line. Bluish green line with a 4861 angstroms of wavelength. And third important prominent line is a blue line with a wavelength of 4340. A blue line you will find. Blue line with 4340 angstroms. These are the prominent colored lines which are observed in what? Balmer series. Please remember these points. And visible line, violet light is there. Violet colored light is observed with a wavelength of 4102. Violet line with 4102 angstroms. These are the 4 prominent colored lines in visible region. I mean in Balmer series. Okay, you may get one question based on this also. Okay, from the hydrogen spectrum. Okay, please note down this. Right. So this is all about what? Hydrogen spectrum. Okay. Right. Then we'll go for the next topic, that is de Broglie's wave equation. Photoelectric effect and de Broglie's wave equation. Okay. So up to here we will be learning in this video, and in the next video we will be learning for the next coming topics. So now photoelectric effect. What is meant by this? You all know. If photons means particles of sunlight. Okay, now photoelectric effect. Particles of sunlight are called as photons. According to Louis de Broglie, okay, please remember, according to Louis de Broglie, electron is traveling in the form of waves. Okay, electron is having dual nature. Means what? Electron can behave in the form of waves as well as it can behave even in the form of particles also. Okay, so if you go for that, that can be observed by the phenomenon of what? Photoelectric effect. Okay, so when high intensity light is made to pass through a metal plate, then electrons are emitted. Okay, this phenomenon is called as photoelectric effect. High intensity light is made to pass through a metal plate, electrons are emitted. This phenomenon is called as what? Photoelectric effect. So based on this, okay, Louis de Broglie has proposed dual nature for electron. Okay, dual nature. So Louis de Broglie was telling electron is having wave nature as well as particle nature also. Okay, dual nature of electron. So what does it says? Louis de Broglie. He told that dual nature of electron. That means actually this can be in agreement with Niels Bohr's atomic model also. In Niels Bohr model, we have learnt that mvr is equal to nh by 2 pi. Isn't it? In Bohr's model, we have learnt that mvr is equal to nh by 2 pi, and that is called as what? Bohr's quantum condition. Okay, but Niels Bohr could not able to give mathematical proof for that Bohr's quantum condition. He assumed that the angular momentum is equal to integral multiples of h by 2 pi. That means mvr is equal to nh by 2 pi. But he did not give any kind of mathematical proof for that equation. Now that mathematical proof was given by whom? Yes, Louis de Broglie. Okay, so accordingly, how he has produced his concept? Using Einstein's mass energy equivalence, E is equal to mc square formula is there, you all know. And you also have E is equal to h nu. This is Einstein's mass energy equivalence. Einstein's equation. Albert Einstein gave, okay, mass energy equivalence. This also was given elaborately in my dual nature of electron. Only one video is there, very elaborately. Okay, all your doubts can be clarified even if you watch that video also. This is like a crash course, so I'm going through all the topics, so I'll be going a little bit faster. Okay, so you can watch my previous videos so that you can definitely understand for the concepts better. Okay, so if you are going to equate these two, what you are going to get? mc square is equal to this h nu can be even written as hc by lambda. Okay, here square and c gets cancelled. mc is equal to h by lambda, or in other words, lambda is equal to h by mc. Okay, so this is the wavelength which is called as de Broglie's wavelength. Okay, electron is traveling in the form of a wave with wavelength of h by mc. That is called as what? De Broglie's wavelength. Please remember. Okay, h by mv or h by mc. Okay, so accordingly he calculated Bohr's quantum condition also. Okay, now lambda is equal to h by mv. This is called as what? This is called as de Broglie's wave equation. Okay, so accordingly, if electron is traveling in the form of a wave, okay, like this, a constructive wave, if it is traveling in the form of a wave, the circumference of the wave is equal to what? 2 pi r is equal to n lambda. Okay, but in place of lambda you can keep here c or v, both you can keep, h by mv also, or you can even also keep h by p also. P stands for what? Momentum. Please remember, mv means momentum, m into v, mass into velocity, stands for what? Momentum. In place of mv, you can take p also, h by p, which stands for what? Momentum. So according to Louis de Broglie, if electron is traveling in the form of a wave around the Bohr's circular orbit, this is Bohr's circular orbit, and the proposal of de Broglie is electron wave will be traveling like this. Then the circumference of the wave 2 pi r is equal to n into lambda. N stands for orbit number. Please remember, n stands for Niels Bohr's orbit number. So in place of lambda, I am going to keep h by mv here. So 2 pi r, the circumference of the wave, is equal to n into h by mv. If you cross multiply, 2 pi r into mv is equal to nh. So mvr, if you leave it like this and bring this 2 pi to the denominator, okay, now mvr is equal to what? nh by 2 pi. So in that way, the Bohr's quantum condition has also been verified. Okay, now Bohr's quantum condition is also verified. Okay, with the help of what? Louis de Broglie's dual nature of electron. Okay, that's why de Broglie's wave equation is always in agreement with what? Bohr's quantum theory, Bohr's atomic model. Okay, so up to here we'll stop this video, and in the next coming video we'll be learning about the second part of atomic structure, that is about quantum numbers and rules to write electronic configuration. Okay, everything, and objectives also I'll try to upload as early as possible. Okay, so I always say, please keep focused, dear children. Okay, if you do hard work, there is nothing in this world that we cannot achieve. Okay, so always your hard work is your superpower. Thanks for watching. Bye.
If you like this video, you just like and subscribe the channel and share this video.